My name is Eric Hutchinson, and today I'm going to be going over copper and the applications of copper in the industrial field. What is copper? Copper is a reddish orange metal known for its conductivity and is and has been commonly used since ancient times. As shown in the top right corner, copper on the periodic table is abbreviated with Cu with the atomic number of 29 and the atomic mass of 63.546 and is found in the 11th group on the periodic table. The history of copper. Copper was one of the first known metals used by humans over 9,000 years ago, and there has been evidence which were tools, jewelry, and early metal workings that shows copper has been used at the start. Copper was one of the most important materials during the Copper Age, when humans began to transition from stone tools to metal tools. Modern industrial uses of copper. Copper is heavily used in electrical, construction, plumbing, and electronics. Copper is a compromising key material for wiring motors, renewable energy sources, and is in high demand because of its reliability and conductivity. Physical properties of copper. The density of copper is 8.96 gram per cubic centimeter. The melting point of copper is 1085 degrees Celsius or 1985 degrees Fahrenheit. The thermal conductivity of copper is 40 is 401 watts per meter Kelvin. The electrical conductivity of copper is 97 to 100% IACS, which means International Anneal Copper Standard. The ductility of copper is that is easily drawn into a wire without breaking. The malleability of copper is that it can be hammered or rolled into sheets. Properties of copper. Copper has a high corrosion resistance because it forms a protective layer of copper oxide or green patina, preventing deeper corrosion. Reactivity. Copper reacts slowly with oxygen, sulfur, and some other acids. Biostatic properties. Copper surfaces can inhibit bacterial growth and is useful in healthcare applications. Non-magnetic. Copper is stable in magnetic fields, which makes it safe for sensitive electronics. Mechanical properties of copper. The tensile strength of copper is 210 to 370 MPa, which varies based on the processing, annealed or cold worked. The modulus of elasticity of copper is around 110 to 130 GPa. The fatigue resistance of copper is good resistance to cyclic loading, making it ideal for springs, connectors, vibration foam applications. And copper has a high toughness, which means it maintains strength even at low temperatures. Other properties for end use when it comes to copper. Electrical use. Copper is the industrial standard for electrical materials because of its near perfect conductivity and reliability. Thermal use. High heat conductivity makes copper perfect for heat sinks, HVAC piping, car radiators, and cookware. Corrosion resistance. Its natural oxide patina layer prevents deep corrosion, allowing long lifespans in plumbing, marine, and outdoor structures. Recyclability. Copper is 100% recyclable with no loss in mechanical or electrical performance. Nearly 30 to 40% of copper used today comes from recycled material, lowering production costs and energy consumption. Processing when it comes to copper. The main ore copper is extracted from is chalcopyrite. The two main refining methods for copper are prim- pyrometallurgical smelting and hydrometallurgical processing. The fabrication method for copper are casting, rolling, extrusion, drawing, and alloying. And copper alloying. Copper alloys are made by first melting the alloying material, then melting the copper to add to it. The molten mixture is then cast and allowed to cool and solidify. Copper alloys. The two most common copper alloys are brass, which is mixed with zinc, and bronze, which is mixed with tin. Brass is really popular because it's used for things like plumbing parts, musical instruments, and decorations. Adding zinc makes brass stronger and easier to shape. Bronze is a lot like copper because it has good heat conductivity, it bends well, and it doesn't rust easily. Even in salt water, that's why bronze is commonly used for things like bearings and bushings. Copper testing procedures. The Some testing methods for copper are the tensile testing measures, which are the measures that measure strength, elongation, and ductility. The hardness testing, which they use Brinell, Rockwell, Vickers tests to measure resistance and indentation. For the conductivity testing, they use eddy current or direct resistance testing to ensure electrical performance. For corrosion testing, they use salt fog testing, immersion corrosion tests, patina development tests. For ultrasonic inspection, they detect internal cracks, voids, or inclusions. For X-ray tests or radiographic tests, they ensure casting and weld integrity. Copper testing standards. Copper materials are regulated by the ASTM, American Society for Testing and Materials, ASTM B152, which is for sheet copper, ASTM B170, which is for oxygen free copper, ASTM B42, which is for seamless copper pipes. There are many more testing standards. These are just some of the ones that I saw according to the websites and sites that I researched them on. Industrial applications of copper. Copper is used in many industrial settings like the electrical industry, which is used for power transition cables, electrical wiring in buildings, motors, generators and transformers, bus bars, and circuit breakers. It's used in construction energy industry. It's used for roofing, gutters, and flashings, architectural panels, decorative building elements, and many more. To add on to the last slide, it's used in the plumbing industry, which is used for pipes and tubings, water supply lines, refrigeration and HVAC coils. Copper corrosion resistant makes it ideal for long-term water use, which is why it's used in the plumbing industry so heavily. It's used in the automotive industry for electrical vehicle motors, wiring harnesses, radiators, and heat exchangers, batteries, and terminals. It's used in a variety of other things like industrial machinery, heat exchangers, and welding consumables. My concluding statement about this presentation on copper is that copper is one of the most important and widely used materials in everyday life, and through studying it, I learned just how valuable it is. I discovered that copper's unique combination of properties, such as its electrical and thermal conductivity, excellent corrosion resistance, and strong ductility, makes it essential in countless applications around us. It's used to help power our homes and electrical devices. It's used through electrical wiring. It helps remove heat and electronics and appliances. It plays a key role in plumbing, construction, and automobiles and renewable energy systems. Overall, understanding copper helped me realize how much we rely on this metal every day and how its properties allow modern technology and infrastructure to function efficiently and safely.